So the first thing I'm going to have you do is work through this warm-up. You will need a graph for it and the whole chart, as you can see. For the rest of the notes, you will also be graphing. So if you want to take a second to get your graphs ready, you will not need a chart. So you will not need this for any of the rest of the problems we're going to do today, but we will do, I think it's 7 different examples of graphing problems after this one. So if you need to take a second and do that, and then go ahead and complete the warm-up. Pause this video to give yourself time, and then when you're ready to talk through it, just push play and I'll just start talking about it now. So with this one, remember we talked last time, you can technically convert this into vertex form if you want, but if we graph it from standard form, you're going to find your axis of symmetry in your vertex by using the formula x equals negative b over 2a. Where here my b value is -4, so it's -4 over 2 times my a value of 1/2. -4 is +4. 2 times 1/2 is 1, so that means that my axis of symmetry is at x equals 4, and the x-coordinate in my vertex is 4. You don't yet know your y value. You're going to have to plug that in, but when we go ahead, we make our t-chart. We put 4 in the middle, and we're going to plug in numbers smaller and bigger. When you plug the numbers in, when you plug in 4, you should get -2, so that's the y-coordinate in my vertex. When you plug in 3 or 5, you should get -1.5 for both of them. Again, you have an axis of symmetry, so those should be the same since they're the same distance from my vertex. When you plug in 2 or 6, you should get 0. So if you did not get those numbers, take a second to go back to practice plugging those in. But I'm going to go ahead and graph it. Okay, this is a wider parabola because of the half. It opens up because that half is positive. And this is what my graph looks like. Then I'm going to go ahead and figure out the chart over here. So my domain for all quadratics is -infinity to infinity, because you can plug in anything you want and it will go forever to the left, forever to the right. Range wants to know bottom to top, so the lowest value is here at -2. The highest value, it's going to go up to infinity, so it's -2 to infinity with a bracket on -2 right there. For your limits, you're going to pull in your -infinity and your +infinity. This will tell me my left, this will tell me my right. So as x goes towards -infinity, as I plug in numbers over here, my graph is going up. So it'll be f of x equals infinity. And as my graph goes to the right, it also goes up. So it'll be f of x equals infinity as well. Increasing, it is increasing on this right-hand side of my graph. So it is increasing from when x is 4 to when x is infinity, because you're talking about x values. And it is decreasing on the left side of my graph. So again, from when x is -infinity to when x is 4. My x-intercepts on this one are nice because I can see them. I plugged them in before, so it's at 2, 0, and at 6, 0. And my y-intercept, if I plug in 0, so I'm doing f of 0, it's going to be 1/2 of 0 squared minus 4 times 0 plus 6. Well, 0 plus 0 plus 6 gives me 6. So it's at 0, 6. If you have homework questions that you want to talk about as a class, you're welcome to pause the video and do so now. Otherwise, you can save any questions for me when I come back. Today we're going to talk about solving systems of equations by graphing. This part of today's lesson is just a review from Algebra 1, and then part of it extends it into what you now know in Algebra 2. But you actually already know pretty much how to do everything I'm going to talk you through today. We're just combining some different skills that you already have. First thing we need to remind you is what a system of equations is. A system of equations is a set of 2 or more equations in with 2 or more variables. And you learned a lot about these back in Algebra 1, and maybe even a little bit in pre-algebra with some very simple ones. But I will give you a couple of equations and you can solve it. Now you will know how to solve it algebraically from Algebra 1 as well as graphically. Today we're going to focus just on graphically. Your answer to these today will always be an ordered pair in x, y, because we're just going to do 2 variables and 2 equations. We're not going to go into that more part of it. And from a graph, your answer is where they intersect. So where the graphs intersect. Okay, so what we're going to do today is just really practice graphing and identifying that intersection point. Again, I'm going to start with stuff you've done in Algebra 1 just as a refresher, and then go into how we do this with the Algebra 2 equations. But the concept will stay the same all the way through. So when you solve by graphing, there's really just 2 steps, but I'm going to give them to you just to make sure you have them. Your first step is to graph each equation that you are given. Your second step is to identify your intersection point. And today you will see that it could be a point, it could be points plural. Similarly to how our quadratic equations have multiple answers, they usually have 2. This could often have 2, especially when I get to dealing with the ones from Algebra 2. Again, the first things I'm going to give you are going to be Algebra 1 reviews, but eventually we'll work to ones that have multiple intersection points. For each answer, I do expect to see an ordered pair x, y, so that I know you know what your answer is. If you don't write the ordered pair, I will assume you don't know what your answer is, and on your test I would take off points for that. So just keep that in mind while you're doing these. So we are really just going to work through a bunch of examples and make sure you remember how to do this from Algebra 1, and again then extend it into our Algebra 2 content. So you're going to need your graphs ready now. I'm going to color code it to make it a little bit easier, but really we're just going to go through and graph both things. So this first one will be my red equation. And with lines like this, if you don't remember, this is our y equals mx plus b form, your slope-intercept form. The b is your y-intercept, and the m is your slope, or your rise over run. We did that a little bit in Chapter 1, but if you don't remember that, I would definitely write it down. So for this first equation, the red one, my y-intercept is at -4, and then I'm counting a slope of -2/3, so I'm going to count down 2 and over 3. And when I do these, I plot as many points as possible. So those are the only points I can get going to the right, but I'm also going to go up 2 and left 3. And again, kind of extend it as far as I can, because you want to make sure you see your intersection point wherever it may be. So there's the first one. And then I'm going to graph the second one. I'll make this one blue. My intercept is at +3 this time, and my slope is up 5 over 3 to the right, make sure since it is positive, or down 5 left 3. With most of them that I've set up for you, you should see a nice clean intersection point like we just found. And again, the solution to this problem, you need to tell me this ordered pair, because that's the x and y value for these graphs that matches. This only has one solution, and it's that ordered pair right there. So it would be at -3, -2. And that's done. Okay, go ahead and try this one first if you want to. If you need to just hear me talk through it, that's fine. One thing we're going to have to make sure we do is this first equation is not in slope-intercept form. So if you're trying it by yourself, make sure you put this in slope-intercept form first. But feel free to pause it, or I'm just going to start talking through it now. Okay, this first equation is not in slope-intercept form. Slope-intercept form is solved for y. So we do need to solve this for y. So what I can do, I can add that 3 over. So I would have x plus 3 equals -y, and then divide out a -1. So my y really equals -x minus 3. And then I can graph it just like normal. So I will give you some not in slope-intercept form, and you're just going to have to put it in that form. So my intercept is at -3. My slope is a -1, so I'm going to count down 1 and over 1. This one's going to give me lots of points, but again, I would mark all of them so that you know where your intersection point is when you find it. You're welcome to use a ruler if you need to. There are some at the back of the room if you want to grab one, if you didn't already. So there's my first equation. Then for the second one, I start at +2. It's a -6 slope, which means I count down 6 and over 1, or up 6 and left 1. The nice thing is we already found our intersection point right there when we counted it out. That ordered pair, again, you're not done until you actually tell me that intersection point. So this ordered pair that makes the equations the same would be 1, -4. So again, same thing, feel free to just go through and try this one. This one's going to give us a special case that I want to make sure we talk about. And then I'll just start working through it. So for this first one, we need to solve for y by dividing by -4 across the board. So y will equal this 2 over -4 gives you -1/2 x. -16 divided by -4 gives you +4. So I'm going to go ahead and graph it. My intercept is at +4. Down 1 over 2. Or up 1 and left 2. Gives me this blue line right here. Oopsies. Plot those points in case my line goes off like that one did, so you can still make sure you did it correctly and find those points later. Okay, so for this next one, we also have to solve. So I'm going to subtract the x over. So 2y, oopsies, 2y equals -x plus 8. And then I divide by 2. And I get y equals -1/2 x plus 4. And what I really want you to notice here is that those are the exact same equation. So if I went and graphed it again, I would get all the same points and the exact same line. When you did these in Algebra 1, you learned that there were 2 special cases that pop up sometimes, and they could still pop up here. One where you have no solution and one where you have infinitely many solutions. This is the case where you have infinitely many solutions because of the fact that they completely overlap. Oopsies, that's not how you spell infinitely. N-I-T-E. So you'll tell me infinitely many solutions for this one, and that's your answer. Go ahead and try this one as well and see what you can figure out about it. And then push play when you're ready to hear me talk it through. For this top equation, again, we're going to solve it. So I'm going to subtract 3x, and you get 4y equals -3x plus 16. Divide by 4, and y is -3/4 x plus 4. So you start at +4. I count down 3 and over 4. And again, I'm going to do it in both directions. So up 3 and left 4 gives me the last point I can plot here. And here's my first equation graphed. If I go to the second one, again, you're solving for y first. So I would add the 12. So I'll have -4y equals 3x plus 12. And then you're going to divide by the -4. And you'll get -3/4 x. 12 divided by -4 gives me a -3 here. And so I start down here at -3. And again, I count down 3 and left 4, or up 3, down 3 and right 4, up 3 and left 4. And what you'll notice is these lines have the same slope, but different y-intercepts, which means they will go on and on forever and ever and ever, but they will never actually touch. So parallel lines like we have here give you no solution. So that's what your other special case would look like. It'll look a little bit different when we get to Unit 2 stuff, but it's the same idea of if your graphs never touch each other, you have no solution, and that's what your answer would be. So these 4 problems have been kind of your review of Algebra 1 to hopefully jog your memory back to that. And now we're going to start with ones that look more like Unit 2, where you're going to have a parabola to graph at some point in the equation. Usually, not always, but usually I will give you one line, and so that will be still going back to before, but then one parabola that you have to go through the whole process of graphing it as well. So we're going to start this one by graphing the line, because I think that's easier. So I'm going to go up to a +3. My slope is a +1, and so I'm going to graph this again in both directions. And again, I plot all those points in case my line gets off as I draw so that I know what my answers should be. So that's my line. But this other equation, we know from what we've done this chapter, should be a parabola. And so we need to think about how we would graph this. First thing I told you to do anytime you graphed a parabola was to identify your vertex. This equation is in vertex form, so that means I can just look at it and figure out my vertex. From this, my vertex is at -1, +4. Okay, then I'm going to plug in, again, my numbers around the vertex, just like you would have done on your warm-up. And we're going to plug those in and find those values. When you plug in 0, plugging in 0 here, 0 plus 1 is 1, squared is still 1, so this is -1 plus 4, which is 3, and I would also get that when I plug in -2. When you plug in 1, 1 plus 1 is 2, when I square it, I get 4, so this is -4 plus 4 is 0 and 0. So I'm going to go ahead and plot these points, -1, +4, and then -2, +3, or 0, 3. That gives me one solution there. And then 1, 0, and -3, 0. And what you'll see here is these actually hit in two distinct spots, and both are solutions to my problem. So this hits in two spots because your line and your parabola can intersect in multiple spots, unlike just lines. And so you're going to give me both of these answers as answers. So one of my answers is 0, 3, and my other answer is -3, 0. So both intersection points have to be given. But that's done. So this is very much like what you've done before. We're just making you also graph a parabola like we've been doing in this chapter. Okay, with this one I stepped it up a little bit and gave you two parabolas. I want you to take a minute and try to graph them, and then unpause it when you're ready to talk it through. So I'm going to start with the one in green. With this one, this is technically in vertex form. My h value is just 0. So my vertex, it didn't go left or right. My vertex is at 0, 2. And then I can plug in 1 and 2, and -1 and -2. When I plug in 1, I should get out 3. And same with -1. When you plug in 2 or -2, you get out 6. If you need to take a second and pause the video to make sure you can get those answers, that's totally fine. But I'm going to plot these here. 2 up at 6. There we go. So make sure you know where those values all came from. The second one is in standard form. Yes, you could go through and put it into vertex form if you want. So if that's what you want to do, that's fine. But I'm just going to use my standard form equation. So it's -b over 2a. Sorry, that looks a little sloppy. I'll write it again. My b is -2, so -2 gives me a +2 over 2 times -1. So this is really going to be 2 divided by -2, or -1. So the center of my t-chart is going to be -1. And then I'm going to plug in 0 and -2, -3, and 1. When I plug in -1, -1 squared is 1, so this is really a -1. -2 times -1 is +2, so -1 plus 2 gives me 1, plus another 2 gives me 3. Okay, then when I plug in 0, I get in 2. 0 is almost my favorite one to plug in. When I plug in then a +1, 1 squared is 1, so this is -1. This will be -2, so -3, plus 2 is -1. So I'm going to go ahead and plot these points. So at -1, I'm up at 3, which gives me a solution, which is great. And at 2, or -2, I'm at 2, and at 0, again, another solution, so that's good. I should be expecting a couple of intersection points for most of these. When I graph it, that's what it'll look like. And these 2 points right here are where my graphs intersect. So my 2 solutions to my system are -1, 3, and 0, 2. And the nice thing, you could have also looked at your t-chart. Both of those sets of ordered pairs show up there, and so those are probably going to be my answers. Okay, I'm going to talk you through one more. Again, feel free to just pause it and go through and try it, and then unpause it when you're ready to hear the explanation. Okay, I'm going to start with the line because that's usually a little bit easier to do. If I want to solve this for x, let's see, subtract the x over, so it'll be negative x plus 2 equals negative y. Divide by a negative 1, and I get that y is x minus 2. So I'm going to go ahead and graph it. Negative 2 is my intercept, up 1 over 1. And again, I go the whole way all the way up and down so that I can find my solutions when I need to. Okay. Then when I go ahead and do the parabola, this is in vertex form, so I can just look at it and figure out my vertex. This went left 2 and down 3, so my vertex is at negative 2, negative 3. I'm going to plug in negative 1 and 0 to the right, and I'm going to plug in negative 3 and negative 4 to the left. When I plug in negative 1 plus 2 is 1, squared is 1, times a half is really just a half. So a half minus 3 is negative 2.5, or negative 2.5. When I plug in 0, 0 plus 2 is 4, is 2, squared is 4, that's where I got that from. 4 times a half is just 2, and then 2 minus 3 is negative 1. So I'm going to go ahead and plot these. Negative 2, negative 3, whoopsies, is right there. Then we're at negative 1, negative 2.5. It doesn't want me to graph anymore. And at 0, negative 1. And over here we're at negative 3, negative 2.5. And at negative 4, negative 1. So here is my parabola. Now this one looks a little bit different than before, and I picked this one on purpose. When you look at this, you can see that, so my parabola is going to keep going up in both directions now. My line isn't going to change direction, and these don't hit in the one spot that they're kind of close to each other. This is an example of what no solution would look like. If your graphs will never hit, your answer is just that there is no solution to the system of equations. There's no x value that will give you the same y value in both of them. So again, if you graph it and they never ever seem to hit, they probably don't, and your answer is just no solution.